Hello everyone, this is Professor DePaulo. Welcome back to Psych 220 Fully Online Behavioral Statistics, and I'm going to talk about Lab 2 today. So Lab 2 is accessed the same place where Lab 1 was in through Blackboard. There's a tab for the data analysis that we're doing in Excel this semester, and there's also a link within the weekly guide on Blackboard. So once you click on that link and you open up Lab 2, you'll see a Word document for Lab 2. And when you open up the Word document, I have step-by-step instructions with screenshots to show you exactly what I want to do in this lab. And this lab is going to focus on hypothesis testing. So I'm mainly going to focus on T-test simply because using a Z-test in a research situation is very unlikely. Because with the Z-test, you need to know the population variance, and almost never do we know the population variance. The population can be so large, there's no way to really study it. And so, unless it's something like IQ or SAT scores, something gathered by the census, where you have all the parameters from the population at large, you're not going to be using a Z-test. Most of the time, almost 99.9% of the time, you're going to be using T-test. So for T-test, there's a couple ways to do this. There's a single sample T-test, which is not very interesting and not used much in research, and that's basically testing one sample against some kind of population parameter, like saying, does your sample have a mean of whatever compared to the population, right? And you want to see, like, for instance, like if you were doing, if I was comparing this semester stats classes to the population of the 15 years plus years of stats that I've taught. And I was comparing your grades to 15 years worth of grades of all the students. That would be the population, right? So I would have a mean there, and of that population. Technically, I could do Z if I knew the standard deviation of that population. But let's say, for instance, I didn't know it, and I just had the mean, and I wanted to compare this class to that previous population's mean to see if it was different. That would be a one sample t-test. So that's very unlikely to be used in research. And the most common t-tests used in research are the independent groups t-test and the repeated measures or correlated groups t-test. Sometimes it's called paired samples t-test. So those are the two t-tests I'm going to be talking about today. In the first situation, I'm going to have you open the divorce data set that I've provided you. So it looks like this. So it's divorce data set lab 2. So I added a couple other columns to this data set because we're going to be doing some additional tests. So this is different than the original divorce data set that I gave. So use the updated one that's in lab 2. And the first hypothesis we're going to be testing is there a difference in life satisfaction between males and females? So the null hypothesis is that there's no difference in life satisfaction between males and females, because the null means no difference, right? And the research hypothesis or the alternative hypothesis is that there's a difference in life satisfaction between males and females. This is a non-directional test. It's two-tailed test because I'm saying there's a difference. If I said there was a greater amount of life satisfaction for females compared to males, then it would be a directional test. It would be one tail. But I'm not really interested in that. In most research situations, you're using two tails. Very rarely are you going to be using a directional test, although you could. You would need a lot of the literature to back that up. And I really don't know much about, divorcees' life satisfaction. So life satisfaction of people after divorce, I don't know much about that. So I'm just going to use a non-directional test here, two-tailed test. Is there a difference between males and females in life satisfaction after divorce? So I'm going to look at this in Excel, and I'm going to go once again into data analysis, the tool pack that you downloaded in the first lab. So your Excel might look a little bit different than mine, but you're going to have a data analysis tool under data. And if you go to the data analysis tool, the first thing we want to look at is if we're looking at males versus females in terms of life satisfaction. Okay, we have two independent samples. That means we have different people in each group. We also have to look at the assumptions of the t-test. And the first assumption of the independent group's t-test is that we have homogeneous variances, the homogeneity of variance assumption. That means that the variances are approximately the same in the two groups. And so to check that, I can do an F-test for two samples of F-test two sample for variances here that you see on this menu. And this is just going to give me a ratio of the two variances. And if that ratio of those variances is close to 1, that's good. That means that the variances are about the same. If that ratio is very large and it gives me a large F value, let's say 3, 4, or 5 or more, that means the variances are way different and it's going to be hard to run the independent group's t-test. So let's check the variances first. F-test for two samples of variances. Click OK. I want to choose the variance 1. So I'm doing male and female. So click on this arrow thing here. And let's go find variance 1. The first variable, I should say. Satisfaction female. So click on that, left click on that. Selects the whole column, which is good. And now let's check variable 2 range. Click on that arrow. And let's pick male. Select that whole column. So now you see we have those two columns selected. The first column was female. The second variable was male. Make sure you click off labels because we're selecting the whole column, including the label. And then hit OK. And I can just double click this to spread this out, to read it better. You see the means of the two samples. You see the variances, they're very close. One's 0.82, one is 0.77. The F ratio was 1, which is exactly what we want. So in this situation, the null hypothesis states that there's no difference in variances for these two samples, male and female. That's what we want. In this case, we do not want to reject the null hypothesis. So this is one of those rare situations, and there's a few of these, but not many, where I don't want to reject the null hypothesis because I want there to be homogeneous variances. I want to satisfy that homogeneity of variance assumption, which means that the variance of the two samples are the same, or relatively the same. And that F ratio of 1 does it for me. That says the ratio of these two variances is a little over 1, so they're basically the same. Look at the p-value, 0.37. That's not less than 0.05. That's greater than 0.05, so I fail to reject the null. And in this situation, the null is that the variances are the same. The alternative is that the variances are not the same. So I'm happy failing to reject the null here. This is one of those rare occasions in statistics where I don't want to reject the null. And I don't here. So I can say the variances are the same. Great. That means my life is easier as a researcher. So once I've done that, let's get rid of that. I can now run the t-test. So here's how I'm going to run the t-test. Go back to data analysis. And I want, since the variances are the same, I want t-test for two sample assuming equal variances. That means the variances are the same. Now, if you ran that F-test and you got crazy variances that were completely not the same and a big F ratio, you could run this unequal variances t-test. The reason I don't want to run that, I'd rather run equal than unequal variances, is because it's harder to reject the null hypothesis if you do unequal variances. You get penalized for having unequal variances. So as a researcher, I want the variances to be nearly the same or relatively the same I want equal variances because then my test has more power. So it's easier for me to reject the null hypothesis. When the null hypothesis is false, of course. So it just makes it easier as a researcher to run the analysis with equal variances. So let's pick equal variances. So I need to select the two variables again. So click on the arrow, and let's select the first sample. I should say the two variables, not the variances. So I want life satisfaction female again. Good. Now the second variable is life satisfaction male, which is right here. Now it says hypothesized mean difference. This is going to be 0 because the null hypothesis always states that there's no difference between the two samples in terms of the mean. So you could have a null hypothesis that is not 0, but really, what's the point? Unless you're comparing a previously established metric in the literature, there's no reason. It should always be 0. There's almost never a time where you would want to make this not 0. So the null says there's no difference, which is 0. Check off labels because we're using the whole column, so we're using the labels. And everything else is fine. Hit OK. And I can just double click up here to expand these columns. Double click between on the edges here to make it so I can read it. These are the means. They're very close. These are the variances. These are the observations. This is your degrees of freedom, which is n1 plus n2 minus 2. Here's my t-value. It's less than 1, which means it's really weak. And if I want two-tail, I go here. My two-tail p-value is 0.32. You see how this value is much greater than 0.05, the alpha value? So therefore, since this is greater than alpha, the alpha is 0.05, we fail to reject the null. And if I fail to reject the null here, that means that these means are not significantly different. So there is no difference between males and females in terms of life satisfaction after divorce. And that makes sense a lot of times because divorce is not a good thing for either party. And it's not that people all of a sudden, are ready to like party and move on and, enjoy their life right after a divorce. And this shows it, right? That there's, they're struggling. They're kind of in the middle in terms of life satisfaction ratings, but they're not really high. And one's not higher than the other. So divorce is generally not a good thing for both parties. It's a very common event, but it's not a pleasant event usually for both parties. So you see no difference between males and females in terms of their life satisfaction after divorce. They're basically the same. And that makes sense. That's not too surprising that there's no difference. So that's how you do the independent groups t-test with equal variances. And the unequal variance one will just give you it'll give you a fractional degrees of freedom, so it's going to change your degrees of freedom. And if you did unequal variances, it's going to be harder to reject the null. And so do equal variances every time you can. If you can't, your data probably needs to be altered in some way, or you need to get a bigger sample, etc. So that's that. And I've given you the walkthrough for this step by step in the document. And I've done the whole thing step by step for you and written this all out to help you out. So use the video, use the document, whatever it takes. People like to print something out and then look at it while they're doing it. Other people like to watch the video. I try to do both. So that's the independent groups. Okay. Now for our dependent repeated measures test, we are going to look at, is there a difference in depression after getting divorced overall, from before divorce to after divorce? So for our repeated measures, now what repeated measures is, repeated measures design is when the same people are in each condition of your study. So in any time we're using a t-test, we always have two conditions. So t-test is only two conditions. For the repeated measures t-test, or what they call the paired samples t-test, I think the book calls it paired samples. What you have is you have a before and you have an after. So you have two measurements with the same people. You have the same people before and the same people after. So you're measuring the same people twice, and you want to see, is there a difference? That's a lot different than the independent groups design that we just did, where you had different people in each group, in each of the two groups. Here in the paired samples T, we have the same people in both conditions, usually before and after. And the null says there's no difference before and after. The alternative, in this case, it's a non-directional two-tailed test. It says that there is a difference before and after. We don't know where that difference is. Maybe they have higher levels of depression, lower levels of depression. I'm not specifying. I'm just saying there is a difference. There is a change happening in terms of depression levels after divorce. And in this data set, the higher the value, the numerical value, the higher the level of depression. So let's look at it. So I have two variables here, depression before, depression after. And I want to see, is there a difference between depression before divorce and depression after divorce? So to run this, paired samples, that means the same people are in each condition. We want data analysis again. And we want paired samples t-test this time. Click OK. Variable 1 range, click the arrow. Click on variable 1 right here. Left click. And do the same with the arrow for variable 2. Depression after. Make sure the labels are checked off because I'm selecting the entire column. The difference again is 0. And then hit OK. And here is my analysis. These are the means before and after. So it actually looks like the depression level went down afterwards, but the difference is so small, it's probably not significant, but let's check for significance. We do not have to compare the variances because we're really looking at variances for the different scores, before minus after, or after minus before. So the homogeneity of variance assumption really doesn't apply to this situation. But if you look at it, the variances are almost identical. These are the same people, so you would expect the variances to be relatively similar. Observations, obviously the same people, so the same number of observations. The degrees of freedom are always going to be n minus 1, so 229 minus 1 here is 228. And the reason why we're subtracting 1 is because we're working with different scores. So what we're doing is we're taking scores of depression after, and then scores of depression before, and subtracting. So we're doing after minus before, and we're creating a column of different scores. And that column of different scores is being tested against a mean of 0. So it's like a one sample t-test, where you're comparing it to 0. So I'm comparing the mean of the different scores after minus before, or before minus after, it doesn't matter because we're doing two-tailed test here. And I'm comparing that mean of the different scores to 0. So I'm almost doing the same thing I did with a one sample. So the calculation is basically the same as a one sample test, except that I'm creating the different scores first. As a result, I only lose 1 degree of freedom, so it's going to be n minus 1 here. 229 minus 1 gives me 228. Now let's look at the t-stat 1.02, 1.03. That's pretty weak, it's pretty low. And the two-tailed probability is 0.305. And that is going to be not less than 0.05. That's a lot greater than 0.05. So in this situation, we fail to reject the null. Failed to reject the null hypothesis. Let's go back to, so we failed to reject the null hypothesis, so we go back to the data set. There is no significant difference before, in terms of depression, before and after divorce. So there's no difference in depression levels before or after divorce. Once again, that's, I guess, somewhat interesting. Now, I didn't look at gender here. Could there be a gender difference before and after? There might be, but I would need to add an independent variable there, and then I would end up with what is called a mixed factorial design, where I have one repeated measures variable and one between groups variable. So gender would be the between groups, repeated measures variable would be before versus after. So that's a more advanced design, but that could be interesting to run. You can't really run it in Excel though. So Excel it's got its limitations in terms of more advanced analysis. The benefit of Excel is it's available pretty much to everybody, or at least everybody at BMCC. So it's easy to run the analysis that you need in Excel if you can. But for more complex stats, you wouldn't use Excel. So you would put the data in Excel, format it, and then bring it into SPSS, or you could bring it into even into R, run it in R. And people are using Python now too. So the way it's going is people use SPSS still, people use SAS still, but there's a shift towards R and Python. But that stuff is a little bit kind of hard to explain online. You would need to like get familiarity with that. This is much easier to explain. I mean, SPSS is easy to explain too, but you don't have access to it because we're not on campus. So this is probably the best we can do for now. But there's no difference here between depression before and depression after. Now, the last thing I want to do in this walkthrough is show you how to make a graph. So we looked at these comparisons. We looked at financial problems, male and female. We looked at depression before and after. Now we want to look at how to make a graph to show this difference. So there's a variety of ways to make graphs. The way that I like to make graphs in this situation is to do a pivot chart. So there are pivot tables and pivot charts. I think pivot charts are very useful. Pivot tables are good when you have a tremendous amount of data and you need to layer it and then like filter it. And so I've done plenty of pivot charts when I was working in industry, in corporate. Although working in corporate is kind of hard. I'm not a big fan of corporate. And now that I've have a research and a faculty position, I don't do as much pivot tables as I used to. But pivot charts are useful for showing graphs in Excel. And I'm going to show you how to do pivot charts for now. Obviously, if you have access to R, SAS, SPSS, these things make a lot better graphs than Excel does. I'm not a huge fan of the graphs in Excel, but since we're working within Excel, it's a pretty easy thing to do. I'll show you the basics of pivot charts. So you go to Insert, and you'll see Pivot Chart. Right, so Pivot Chart's asking you to select the range. So click that arrow again. We want to select those variables that we just looked at, which was life satisfaction, male and female. So let me move this out of this way. I want to select this column and this column. So those two columns selected, right? And then hit OK. And those are the only two variables I put here. So here are your variables. I mean, you can select the entire data sheet if you want. But if I'm only looking at these two variables and making a graph, I just selected those two columns. So if I want to make the pivot chart, let's put these two columns in the values box. So I'll just click and drag into the values box, right? And I don't want sum. So right now it's giving me sum of the values. and sums are not really useful to look at. I'd rather look at means. So let's look at average or mean. So if you click these arrows, you want to go to value field setting, and you want to click on average instead of sum, hit OK. And then I want average for the second one as well. So click the second one, value field setting, click on average, and now you have your averages. So here's your, and you can just copy and paste this chart into whatever you want. And that's your pivot chart. And it's useful. It shows the difference. Now, these are not significantly different, even though it looks big. The reason it looks big is because the scaling on the y-axis here, it looks like a bigger difference here, and this is why people can, trick people with graphs. So, Excel is not trying to trick you, but it's showing a pretty big difference here. If you wanted to change this, you can then check this off, right? And let's say I made this, instead of going from 4.68 to 4.88, let's go from 0 to 5. And you're going to see this shrink. Now, you can just click and paste this. If you paste this graph, it's fine. This is the chart. If you want to paste this bar graph, I'm perfectly fine with this graph. But if you want to see the distortion in the graph, look what happens when I set this to 0. So I'm going to set the minimum value to 0. There's too many decimals there. Well, let's set the maximum value to 5. Let's make this 5. Look at that now. Now it definitely looks like there's no difference. Before, it looked like there was a huge difference. Now that I scaled it from 0 to 5, it looks like there's really no difference. So I would say this is a better version of the graph. Even if I wanted to go from 4 to 5, that would even look more fair than what we had before. So Excel's giving you like this huge spread that it was showing before, but in reality, if I just change the axis, it really does, it doesn't look distorted anymore. It looks basically the same. It looks like female is a little bit higher, but not really significantly higher, and it's not, because these are not statistically different. But they look huge when I showed you the first version. So if I go back to the first one, there, that looks like a tremendous difference, and there's really no difference. And the reason it looks tremendous is because we're starting at 4.68 and we're ending at 4.88. So it's just basically stretching out that really small amount. It's kind of stretching it out. So this is a distorted graph versus something like this, or even like this. This is a more realistic graph, starting at 4 and ending at 5. So you can do that by just clicking on the axis. But all the graphs they're all viable. It's just that one is kind of like really showing a difference when there really is no difference, and that could be distorting to your audience. So just copy and paste any version of the graph that you want. That's correct, right? It's done this way, and that's good enough for me. I'm just pointing out the way you can kind of sort of toggle the axes and try to exaggerate the claim. And you see this in conferences, you see this on TV when they're presenting evidence of things. You see these graphs that just kind of distort reality. And they're not incorrect. I mean, they're not incorrect technically. They're fine graphs. They're just distorted. They're misleading. And a graph like this that I'm showing you now is not misleading. It's a pretty accurate state of what happened, of the results, versus what I showed you before, where it was kind of really stressed out. So, and that's the default setting for Excel, but you can always change it, like I did. So hopefully that helps explain what's going on here. And after you're done, so I basically gave you all this in a step-by-step walkthrough with screenshots, which takes quite a while to make. I even posted the distorted graph here, but you can always change it if you want. What I want you to do is do these 3 problems for the lab assignment, and I want you to put it into a PDF file at the end. So save everything as a PDF file, and then I'll put a link to upload it. like we did the last time. And the last lab was done pretty. It was pretty good. I mean, there was very few problems with it. I think everybody figured out the basics of it. I had no real issues with it, unless you didn't do it. But for this exercise, I want you to test the hypothesis that men, sorry, I put a typo here, and women differ in financial problems following divorce. So men and women differ in financial problems following divorce. So there is a financial problems female and a financial problems male. So let's go back to the raw data. So you see here, there's a financial problems female and a financial problems male column. I want you to test those to see if these are different, these two variables. Are the means of these two variables different significantly? And that's going to be independent groups t-test. So check the variances first, and if the variances are equal, run variances equal, and then report the results. So you can just copy and paste the table and then tell me if it's significantly, if there's a significant difference or not. So I want to see that. And that's the first one. For the second one, I want you to look at hopelessness. Does levels of hopelessness differ after divorce? So this is paired samples. And so I've given you hopelessness before and hopelessness after. I want you to test to see if they're different. This is a paired samples. These are the same individuals in both groups. This is before divorce. This is after divorce. Is there a difference? So give me the output. Let me know, is it significantly different or not? Give me the p-value, give me the t-value, and let me know. And the last thing I want you to do is generate a bar graph showing the difference between financial problems for females and males, similar to what I just showed you. Generate the bar graph and show, to show is there a difference between males and females, and just copy and paste that into your assignment. Save it as a PDF, upload it at the link I provide you, and then I'll take a look at it. And generally, the first one was really good, so I don't really have a problem with it. But if you have an issue with doing any of this after all of this, let me know. But I have the handout for you that I'm going to post online, and then the video that I'm making right now to post online.